Hi. So we're looking at this first problem, or just any problem really, right? You have the first problem in the homework. You have a car, goes 30 meters, takes 8.5 seconds to do it, and it's going to slow down to 3 meters a second, which means it's going faster in the beginning and it slows to 3. We can probably reason a little bit, right? Somewhere in the middle it'll be going the average speed, and you can calculate 30 meters and 8.5 seconds. You can calculate that average speed. This is more about what do you do when what you want to do is try to figure out what is going on and what you can do to find any of these things here, right? We need to know the initial speed that it starts at, and we need to know the acceleration. All right. So given it asks it in that order. We want v initial and we don't know the acceleration. That's what I would start with. I would look at those things and say, the things I don't know, is there something I can ignore? All right. Looking at the kinematic equations that we have, right? If you're working on the problem, you should probably have these on your formula sheet with you. 3 of these equations have the acceleration. If I don't know the acceleration, my first guess is to say, don't try to use that to get v initial. Can I use something else to get v initial? Can I use that third equation, which I'll write down here? So delta x is 1/2 v final plus v initial times t. Do I have everything that's in that? I have the time, it's going to be 8.5 seconds. I have delta x, it's going to be 30 meters. I have v final. Yeah, that seems reasonable. And so I can take this equation and I can rearrange it. All right, I can do, multiply both sides by 2, so that cancels, and then I can divide both sides by t. All right. And then I'll have v final plus v initial equals this fraction on this side, and I can solve for v initial. V initial will be 2 delta x over t minus v final. And I know everything in that. I can start calculating from there. That's what I would do, is always have these kinematic equations nearby. Have them either in mind, in a textbook, written on the formula sheet. And until you've internalized those, reference them and say, this is how these things were related, one thing to another. And then you go through and you say, well, I don't have this. Can I ignore it? Can I use can I use an equation that doesn't have it? So let's, go back and say, let's try to find the acceleration the same way. We don't have v initial. Is there an equation that doesn't use v initial? Unfortunately, no. They all do. I'm going to have to get it somewhere. So that's kind of a clue, is if I'm trying to calculate something, odds are I need to try to use a formula that I actually know everything for. I'm going to have to try to pick one of those out. When I'm trying to find v initial, I don't need the acceleration for this one. When I'm trying to find the acceleration, I'm going to need v initial. Now, there is a way around this. What I can do is say, like we did in some of the other things, I have a pair of equations here. Can I eliminate v initial? And so I'll show you what that would look like if I wanted to do the acceleration first, which I don't want to do necessarily. But if I wanted to do that, what I would do is say, here are my 2 equations. Delta x is 1/2 v final plus V initial t, and V final equals V initial plus AT. And what I want to do is eliminate V initial. So I'll go and I'll say, well, get V initial by itself. So I'll add minus AT to both sides and get rid of it. V initial is V final minus AT. All right. And then I can plug that into this other equation. Delta X is 1/2 V final plus V final minus AT, and then T. And this is like when we derived this other equation. Let me bring that back up. This one, the V initial t plus 1/2 AT squared. When we derived that in the notes, we had to do some algebra. And we have to do it here. We're just going to group things and distribute. All right, this is going to be 1/2 2V final minus AT times T. And that is going to be, all right, I notice I'm running out of space here. So delta X is going to be 1/2 times 2 is V final T. I'm going to have 1/2 AT and T. So minus 1/2 AT squared. And so I could come up with one of the equations if I didn't know it. All right, if I wanted to do this, I could do that. I don't recommend this. What I would say is go back up here, ignore that stuff. I want to find V initial. So I want to work with an equation that has V initial first. Once I know this number, then I can include it in what I know, and then I can use something else. I can go and say V final equals V initial plus AT, and I can solve this for the acceleration. And it's a lot easier if I'm trying to solve a problem to start with recognizing I don't have V initial. Go ahead and get it, because every equation that I start with uses it. Don't try to derive a new one, but you can do that if you want. So again, with what we're doing, you have this problem, or you have a problem. Note the things that you don't know, right? Whether they're goals or not goals, whether you want to know them or not, note what they are, right? And say, I want to find V initial. I want to find the initial velocity. I don't know the acceleration. That eliminates 3/4 of the equations, because 3 of them use the acceleration, 1 of them doesn't, and so we use the one that doesn't. Delta X is 1/2 V final plus V initial times T. If we have enough information, that's great. If we don't, then we're going to have to find something else, right? Or we're going to have to do like we did here, is use 2 equations to build a third one, solve some system of equations. Yeah, that's 9 minutes to explain how to do number 1, but it's hopefully more general, right? Hopefully you start with, you've organized your info and you're like, well, how do I pick an equation? Look at the things you don't have and say, I don't want to use equations that use that. Can I still do it? And in this case, you can. In other problems, you may have to go and find something else. You may have to do the problems out of order or do a system of equations, something like that. So, again, I recommend have this set of equations in front of you until you've got those burned in your brain, that you remember what those 4 are, and just go through and say, I don't have this variable in it, so I'm not going to use it. I don't have it here, not going to use it. Don't have it here, not going to, pick the one equation that you do have and use that. I hope this helps.